Hi, today we're going to be covering 6-7 exponential growth and decay, which is what we did in 6-6, but now we're talking about it from word problems. So it's going to be specific scenarios, and we have a specific formula for growth and a specific formula for decay. For growth, the formula, and growth is going to be when it increases. When it's talking about increasing, then it is growth. And that formula is y equals a 1 plus r raised to the t. What you may notice is that this is extremely similar to the compound interest formula, which is a form of exponential growth. The a stands for the initial amount. The a is the amount reference, but it's the initial amount. It's what you start with. The r is the growth rate, which is your rate, and that's going to be as a decimal. As a decimal. Make sure you can see everything that I'm writing, yes. Okay, and then the t is time. All right, so here we go. So stick with that. T is time. So I'm bolding that. All right, so here we go. Let's look at number 1. It says the original value of an investment is $1,400. So that information right there tells me my A, because original is the same as initial. So my A is 1,400. And yes, you have to write down what the A, the R, and the T are, plug in the information at the formula, and then we're going to punch it into the calculator and get our answer. You have to have all of those parts, not just the answer. Okay, and the value increases by 9%. So increases, that tells me this is a growth. And there's my rate because it's a percent. Oh yes, this is a percent as a decimal. So my R is going to be 0.09 because you have to move the decimal twice. And then it says each year, use the exponential growth function to find the value of the investment after 25 years. So my T is 25. So now I'm going to take these numbers and I'm going to plug them into this formula in the spots where they go. So I'm going to have y equals 1,400, open parentheses, 1 plus 0.09, close parentheses, raised to the 25. I do not have to do any simplifying at this point because I'm just going to take the handy dandy calculator and plug it in exactly as it's written. So I'm going to clear this. Now I'm going to do second quit to get out of that screen. And now I'm going to punch in all of this. Cover up that y equals. I'm punching in all of this into the calculator exactly like it is. 1400, open parentheses, 1 plus 0.09, close parentheses. Now I want to raise this to the exponent, so I'm going to put the rooftop caret button, 25, enter. Now, I'm talking about money, so that means I have to round to the hundredths place. So my answer is, and we're talking about money, so I have to have my units, $12,072.31. This is my final answer. Okay, so we're just labeling the information in there and plugging it in. Here we go. I'll go a little bit quicker because there won't be as much explaining for number 2. All right. The cost of a tuition at a college is $12,000. So that is my A, because that's what I'm starting with, the cost of the tuition. And that's $12,000. It is increasing at a rate of 6%. So my R is going to be 0.06. Use an exponential function to find the tuition cost after 4 years. So my T is 4. So we plug in and I have y equals 12,000, open parentheses, 1 plus 0.06, close parentheses, raised to the 4. And we plug it in. just like it's written. So I'm going to have 12,000, open parentheses, 1. And I could actually do this addition together because you know that this is going to be 1.06. If you don't, then type it like we did above, and that's okay. Raised to the 4th power, enter. And we're dealing with money again. So I have to have my units. So we have 1, 5. Most of the time we do deal with money. 149.72. When it's not money, you have to think about what is your answer going to be. Like for instance, in number 3, use the exponential function to find the number of student athletes. So therefore my answer, instead of having the money symbol, we'd be talking about student athletes, the number of student athletes. Okay, now we move on to exponential decay. It's the same, similar process, we just change the formula up a little bit, which means we change from a plus to a minus. Because we decrease, it's a decay. Notice the DE, and my formula is y equals a, open parentheses, 1 minus r, close parentheses, raised to the t. The same, the symbols means just about the same thing. A is still the initial amount. The R, the only difference, it's the decay rate. Instead of growth rate, it is the decay rate. But it's still the percent as a decimal. And the T is time. Okay, so let's look at number 7. It says the population of the town is decreasing. Decreasing, that's my clue that this is a decay at a rate of 1%. So therefore I know that my R is going to be 0.01. In 2000, there were 1,300 people. Use an exponential function to find the population in 2008. Okay, notice I didn't automatically jump to saying what the A was because I had to finish reading the problem. I know that the 2000 is the beginning because it wants me to find out what it is in 2008. So I'm going from here to here. So the 2000 is representing the initial amount. So A is 1,300. T, well, I got to figure out how many years is it from 2008 to 2000. So that means I'm going to subtract those. I'm going to do 2008 minus 2000, which gives me 8. And I know that you can do that in your head. I just want to make sure that you understand what you are doing to get to the number 8. And now we plug it into the equation, to the formula. Y equals 1,300, open parentheses, 1 minus this. You can't, subtraction you can't do in your head as quickly as you can do addition. So this I would leave it as the minus there when you type it into the equation, into the calculator. 1 minus 0.01 raised to the 8. And now we plug in. And we're going to have 1,300, open parentheses, 1 minus 0.01, close parentheses, raised to the 8, enter. And so we're going to have, we're talking about people. Can I have a fraction of a person? No. So I'm going to, once I start that person, I have to finish that person. So therefore, this answer here is going to be 1,200 people. Okay. Now, hopping down, I'm going to talk about number 12 just a little bit. I want you to pay attention to the percent here. Remember, you have to move the decimal twice. So this is going to be 0.025, not just 0.25. That's a common mistake that can happen. So be careful with that. All right, your assignment is to finish the notes and the classwork homework. Y'all have a great day. Bye.